I'm now going to go through the Module 10 project exercises. Make sure you attempt them on your own before looking at this video. All right, number 1, use a list comprehension to create a list that divides each of the integers 0 through 9 by 4. Okay, so this is pretty simple. Let me just write the for loop first for I in range 10. So that's 0 through 9. That's the for loop part. The expression part is simple. We're just going to divide it by 4 and get that. All right, number 2, find the difference between twice a number and the square of each number for all the integers 0 through 9 using a list comprehension. So again, the for loop will be the same for I in range 10. Let's go back over here. Find the difference between twice a number. So twice a number, the difference means subtraction, and the square of each number. So that's my expression over here, twice a number minus the square for all the numbers 0 through 9. All right, number 3, use a list comprehension to concatenate the first and last characters of each of the strings in the following list. So I'm going to go through each one of these strings, and I'm just going to concatenate the first and last. So here, L and T, C and S, R and K. So let's go ahead and create our list for word in words. And to get the first character, it's word 0, and we're going to concatenate, which just means add, and the last one. So here's our expression, word 0 plus word of -1, and that will do it. Exercise 4, use a conditional list comprehension to return all of the strings from a list of strings that have the letter E in them. So we want to filter for the words that have the letter E in them. Let's go ahead and do this. So for word in words, so this is just a list of strings. Let's write our condition. If E is in the word. So maybe we want to do dot lower. We're going to lowercase the word and include if there's an uppercase E. Now the expression will just be the word. So this is just a literal filter. Nothing is happening over here in the expression part. And so there we go. So E is found here and there. And I guess if let's just create a word with a capital E. And so that will make it in there as well, although there's another E over here. So just say eat with a capital E, and that will still make it because we are lowercasing the word before checking for the lowercase e. All right, exercise 5. Use a conditional list comprehension to return a list of just the vowels of the following string. So here we have a string, not a list. And we can still iterate through this with a list comprehension. So for car in letters, or maybe we just say letter in letters to match that. And what we want over here is just the vowels. So again, we have to use a conditional list comprehension. So we'll say if the letter is in, say A-E-I-O-U, we can also just make it capital A-E-I-O-U like this. So if it's one of these, then it'll pass the filter. So the filter is if the letter is in this. So I've created a string over here, but it's a string of just the vowels and lowercase and uppercase. And then the expression is just going to be letter. So that will do it. So there's lots of vowels over here. It doesn't matter if it's capital or lowercase, because as long as it's one of these, then it will be good. All right, number 6, write a list comprehension that loops through all numbers between 0 and 49, filters them for those that end in 3 or 7, and then squares the number. Okay, so a lot going on over here. First, we're going to write our list. So for I in range of 50, that's 0 through 49. Then we'll write our filter that end in either 3 or 7. So how do you get a number that ends? If I divided by 10 has a remainder of 3. So this is how you get the last digit, is you divide it by 10, and that'll give you the last digit. Or I divided by 10 equals 7. So let's go ahead and filter for this first and not do the expression right now. Let's just look at this. So yeah, 3, 7, 13, 17, and so forth. So that looks good. And then squares the number. So the last thing we can do is just square it. and that will give us the correct answer. All right, number 7, the ranges below contain the lengths and widths in feet of rectangular rooms that will be tiled. Okay, so we have some rooms that have a length and width. So this goes from 10 to 30 by 5, 2 to 40 by 2. And then the price per square foot for different tiles is given in the price list. Okay, so either $1, $2, or $4 per square foot. Use a list comprehension to return the total price for each room, but only if the room is greater than 800 square feet. Okay, so again, a lot going on here. Let's write our for loops over here. So this is going to be a nested for loop. So we want to calculate the square footage of the room. So each room has a length and a width combination. So we'll say for L in length, for W in width. So I've done a nested for loop. And then what I'm going to do is I'm only going to filter for the rooms that have, if it's greater than 800 square feet. So if, to get square feet, we just multiply L times W, because it's rectangular. And if it's greater than 800 square feet, it will pass the filter. Okay. And then finally, and maybe we want to just print this out first, so I'll just print it out with I'll say L and W. Say length is, width is, okay. So there's only a few here that meet this criteria of greater than 800. When you multiply these two together, they will be larger than 800. And what I want is, I want to get the price per square foot. So what I actually need to do is, I need to go through each one of these combinations of price. So I need to do for P in price, and I don't want this, I'm not going to print out a string anymore, although I guess I could. And yeah, why not? I'll say price per square foot is L times W times P. So there's a whole lot going on here. And I should actually put the price. So I'll say price, and there's way too much going on here. You can see it's off the edge of the screen. And let me just press enter over here so I can see it. Okay, so what's happening here is I have this triple nested loop. So for L in length, for W in width, for P in price, it's going through all those combinations, and it will only do the expression part of the list comprehension if the square footage is greater than 800. So L times W is greater than 800. And so if the price per square foot is 1, then it'll be 850 here, 2, and then $3 per square foot, and so forth. Okay, so a lot going on. We could have done this a little bit if we just wanted let's just get rid of all of this and just, we don't have to print it out. Let's do L times W times P. That way we can have it reasonably on one line of code. So this is just the straightforward way of doing it, just getting the final price. All right, exercise 8, rewrite the list comprehension in exercise 7 using nested for loops and normal if-then statements. Okay, good. So this is probably a case where you would want to use normal nested for loops. Let's go ahead and we'll go ahead and copy and paste this over here. So for L in length, okay, we need do it normally. So we have to put the colon back for W in width, for P in price. And finally, once it's gone through here, if the square footage is greater than 800, and we could actually put this up here, by the way, but I'll just keep it here for now, then we will create a prices list and append the actual price, L times W times P. And here we'll put the prices over here as an empty list. And then finally, we'll print it out. So that'll give you the same thing. So it's going to iterate through each one of these lengths, each one of the widths, each one of the prices, and only if the square footage is greater than 800 well, will we actually go ahead and calculate the price? And probably a better way of doing this is to put this if statement here. And you cannot do this in a list comprehension, or the way we set up this list comprehension. But we'll say here, only do this inner loop, this last inner loop, if the meets this criteria over here. So this is actually a little bit more efficient way of going through this problem. So we don't even have to do this loop unless the square foot is greater than 800. So this would actually probably be a better way of using it. It's still pretty complex because it's so nested over here, but that's the only real way to answer this problem. All right, so that completes all of the exercises for Module 10.